Um, so welcome everyone, good morning. And for me, it's good afternoon, and I'm sure people watching this might be any time of day if they're watching later on a recording. My name is Christopher Jones. I work at Oracle in the data access team. I have worked for Oracle for a number of years in a number of teams, always in the database access API area. I'm a product manager, so I get to do conferences, I get to speak to customers, I get to review specifications, I get to write some code and documentation and do all the legal bits and pieces and just liaise generally with all of our fantastic users and consumers of Oracle technology. So my wider group looks after all of the data access APIs, and me more specifically, I look after the C stack APIs, so Python, Node, PHP. I spent a lot of my early years with PHP, actually in our Linux group here at Oracle, working on upstream PHP and the Oracle data access layer for PHP. Now my portfolio has widened quite considerably. I'm hiring and all sorts of things. It's all looking good. Obviously today we're going to be talking about the Node Oracle DB driver, which is the data access API for the Node.js space, and also usable with TypeScript, as some of you might already have used. Open source. See a significant number of users, downloads looking great. It's very stable. It's been out for some years now. You can contribute back to it if you like. You can install it with Yarn or NPM or any of those sort of other package managers. I probably don't need to explain Node.js to you. It's the, the JavaScript in the application tier and in what the database world would call the mid-tier. The driver itself, the API, the module has a huge number of features. We're not going to get time to talk about all of these today. I have a little asterisk there. If you do scan down quickly next to two-phase commits, we have a release due out hopefully this week. I'll be checking on the testing status when I finish this talk. And the two-phase commit feature, well, it should land sometime this week, if not early next. But today we're going to talk quite a lot about connection management, because that's quite an important topic for Oracle people. I want those connections to be available, highly available, reliable, fail over nicely. And we're going to talk about getting data in and data out, making that efficient, and also talking a little bit about the JSON storage in the database, which is a fantastic way to use Oracle database. It's always hard for me to know what the background is of people coming to these talks, so this is just the bare basic hello world kind of script. Node.js, JavaScript, you may be familiar in the front end and in the browser with a callback style. Node.js, more recently, we have this async await style, and that is, as you can see, async on the functions and then await for when you're calling a function. This just makes the code flow a lot cleaner and easier. Standard GET connection, password here is hard-coded, but we have all the standard Oracle external authentication, wallets, that kind of fantastic stuff. Execute, this results come back, so there's no separate fetch in this case. Print the data, and obviously we want to close the connection and release the resources. Binding, always worth mentioning, because there's always someone who hasn't heard about binding. We don't want to be passing data as part of the SQL text for that. We want binding because that gives us scalability, gives us security, because the SQL never can be injected by the user data. So I'm kind of rushing through because I tend to run a little long, but certainly feel free to ask questions if you need to. So the stack diagram is a thick stack. So we have our drivers part of Node, and then we still need some Oracle client libraries to be installed. I mean, if you're in the Java world, you've got to install the JDK or JRE. In the C stack world, you have to install the Oracle C libraries in the Oracle call interface. Obviously, your users are out here. They're using their Angular apps, whatever they are, doing some web service requests, coming into Node. Node is then calls coming down to the application code into the C interface libraries and across the network to Oracle database. Can be in the cloud, can be on-premise, whichever way you like. So Node itself is a relatively thin layer. My shorthand. Node Oracle DB is obviously a relatively thin layer on all of that technology, which is in those client libraries. So under the covers, the Oracle client libraries provide data access, buffering, fetching, compression, performance. They provide the high availability. Some things we're not going to talk about today, such as application continuity, is all baked into those Oracle client libraries, the thick stack. It's well tested, well used, widely used. Oracle Net, as you know, is not a separate product. It's just the protocol across the database. That provides a lot of other functionality, like the connectivity, encryption. So if you look at the Node Oracle DB manual, you'll find just a little bit of a mention there, perhaps, about encryption, because really it's not a Node Oracle DB feature. It's part of the Oracle Net feature. So you go into the Oracle Net documentation to look for how you can configure those in the various ways that are possible. Overall, it's a very solid stack. So how do you get started, or starty? I see a typo there, last minute typo. Install Node.js itself, downloadable from the community, or if you're on the Linux world, the Oracle has RPM packages. You need a thick client. You only need this if your database is not on the same machine as Node.js itself. Those client libraries are part of the database stack. So if you're running everything on the one machine, you don't need to do this. But if you're on separate machines, then you would want to install our instant client. That's a DMG for Mac. It's zips for Windows, RPMs and zips for Linux and other platforms. You can download it. There's no click-through. You can script it. It's very easy to install. Node.js World works with a sort of package application specification format for those who haven't used it. You put your dependency on the packages you want to have installed, Oracle DB, and I've jumped the gun by saying 5.3, which is the release just coming up in the next few days, as I mentioned. Obviously, you need to create your actual application. So you have a JS file here, just have a single file application. You run npm install, or if you're using one of the other package managers, such as Yarn, you can use that. That then looks at this dependency settings in the package.json and installs all of the modules that you want to have installed. And then you can run npm start, and that will run this start script. And whatever command you've indicated as the start of your application, it will fire off. There are some quick start instructions on oracle.com. There's some nice setup there. There's effectively two, one for cloud and one for on-premise database. And then it has separate instructions for Mac, Windows, and Linux for each of those three things. So if you haven't used any of this before, go and Google for that and work your way through it. So we've installed the components, but how do we actually hook them together? We've got these client libraries. How do we tell our Node app to use those client libraries? We have inside the application, we need to do standard require. So we actually load the module itself. And once that's loaded, then we can just use this init Oracle client and say where those libraries are located. Obviously, // for Windows, Darwin is Mac OS. Windows, you can alternatively set your path environment variable, so you wouldn't need to do any of that code on the screen, and then that path would just be used by any of your Node apps. On Linux, due to some complexities with the third-party libraries we have included in Instant Client, this doesn't work on the screen, so you actually have to set your LD config or library path before you start your application. Now, if you're using Instant Client RPMs on Linux, that LD config is set for you directly, so you can just ignore this whole slide, just use Instant Client RPMs, never have to do anything else. Mac OS, and I should say Mac OS Intel, we don't have Instant Client for the M1 chip, but for Intel, this is kind of handy since makes things portable. If you have a lot of scripts you might need to update, for example, when we have run our test suite, don't want to have to go through all of that test suite updating paths. So we just have this little post installs script, and we just set up this symbolic link. And Bob's your uncle, as we say in English. Everything just works nicely. A couple of other ways this can be done. This works on Windows as well, and all of that is in our installation manual. But effectively, install Node, install Instant Client, and just hook the two together, and you can write your applications. So we saw a little bit of a sample of a standalone connection before, and that's fine just for a simple one-off application. But most applications will actually be handling more than one user, and they'll be long running. So you really want to be using a connection pool. So you'd use a connection pool when you need a lot of connections concurrently, but for short periods of time. Do some work, finish your work, wait for the next user to do something. You might also use a connection pool if you have a small number of connections, but they're mostly idle, not doing a lot. And the pool supports a number of high availability features. It has some smarts inbuilt. So we'll do dead connection detection. I'll talk a little bit about that later. And it also supports some of our higher end features, such as a database resident connection pooling. Sorry, no time to talk about that today. Application continuity and fast application notification. So if you're in some of those higher end rack clusters, you really want to be using a pool because it supports all of that technology out of the box. So how do you use this? We create a pool. No real surprises there. You do this once at application initialization. You've got some pool parameters you can set for the pool size. Obviously, this is going to start, when the pool starts, it's going to have 2 connections created, as shown by this diagram. Pool's going to be allowed to grow up to about 4 connections maximum, and it can shrink or if it needs to. If it has to grow, it's just going to add 1 connection at a time as each new user wants to access a connection from the pool. App then has to get connection, and the important thing is to close the connection after you've used it. That puts it back in this pool and makes it available for somebody else to use. So this pool will be created at startup. These pipes will be created. These processes in the database side will be created, and the app is ready to run. So when your user requests come in, they don't have to do any of that work. There's no startup cost. There's no teardown cost. These connections are available and they stay available. So they're very efficient for application use. Obviously, when you close your application, you might want to close the pool. Just it's kind of nice to the database to tell the database to shut down all of these connections. And you can have a nice little grace timeout period here if you want some connections which are still in use to continue, but want to block new people getting new connections. So this is a drain time which can be set here. Connection pooling has some parameters I mentioned. Pool min, max, increment we saw. So increment is how pool's going to grow when it needs to get new connections, need to add new connections. Pool time is how is it going to shrink back down if those connections are idle. So we're seeing here 3 users, 3 active connections. 4th one might have been created, so we've got 4 in the pool, but this one's not being used. This one doesn't get used for whatever the pool timeout period is set. It'll just get closed off and we'll go back to 3 connections. Now, what happens if you have a huge burst of users? So you've got another 4 users come in. They can't be using connections because the first 4 people have already grabbed those connections. They're running their SQL statements. So the get connection calls are going to block. They're just going to sit there. They're going to get set in a queue. They're not going to return to the application. So the application user is going to sit there waiting for hopefully the short period of time that user 1 might be done with their connection. And when user 1's released this back to the pool, it's gone yellow, then one of these connections can be popped off the stack and the get connection call will return back to the application. The application can continue. So this is great just to handle those little transient bubbles because theoretically your pool is nicely sized. Users aren't holding onto the connections for a very long periods of time. So they're recycling them, putting them back, making them available for the next user who wants them. If, however, things go wrong, and these connections stay in the pool for too long, past the queue timeout parameter setting, then that get connection call is just going to return an error back to the application. And presumably you'll pass that back to the user and say, hey, try again later. We're overloaded at the moment. The queue actually has an upper limit. And if that upper limit is exceeded, if you have a huge number of users suddenly slam it in the morning and they come in, wake up, then we have another setting, queue max. This is the limit size. I think it's 500 by default. So you can have 500 people waiting for connections. And the 501st user will then suddenly get an immediate rejection. There's not going to be any timeout period for that user. So we've got some ways here to cope with flooding of networks, flooding of the application. So threads versus connections, very important in the Node.js world. Let's start with a little scenario. Say our pool has maximum of 10 connections in that pool, and we actually have 10 users actually trying to do SQL statements. So what could happen? Well, unfortunately, just out of the box, you might see low throughput. You might see some deadlocks, and that is because Node has 4 worker threads. So Node itself is operating in a sort of single process, handling requests off a queue that it's self-managing, but it sends off work down to these worker threads, and there are 4 of those by default. Now, these worker threads are a little different from the recent user worker thread project, which has landed. These are the sort of original worker threads that Node itself is managing. And these worker threads are held in use by each of those connections as those connections are waiting to do work. So if a request is off to the database waiting for a big query to execute, that worker thread is just going to block, sitting there waiting for the response from the database. So that worker thread is unavailable for anybody else to reuse. So the solution is to increase the number of threads. And you would typically set that before the application starts. Here, this is Linux syntax, use set or whatever on Windows. Actually, on Linux and Mac, you can set this runtime in the app, but it needs to be set before the thread pool starts in Node, and that can be tricky to work out. Much safer just to set this before the application starts. Windows, it always has to be set before the application starts. You may actually want some extra threads available for non-database work. Now, the upper limit on the thread pool size used to be 128 in older versions of Node. It's been bumped up to 1,024 in newer versions. That would be a pretty big connection pool. So you probably don't want to go anywhere near that. You want the connection pool to be as small as possible, to be as efficient as possible for reuse purposes, locality purposes. You want to avoid things like trying to do promise.all on a single connection, trying to load a single connection with a lot of requests. Those connections can only handle one thing at a time anyway. So you have to manage your connections a little bit in terms of the application. Now, nothing will fall over. Our driver carefully queues all those requests and waits until the connection is available so they can be executed if you're, again, trying to do a lot of requests on the same connection. But still just be aware that this is Oracle land. The pipe across the network is half duplex, so you can't actually run a parallel set of operations on the single connection. If you want to run parallel operations, you need parallel connections. And here's a tip from the professionals from our real-world performance tuning team. They don't like seeing connection storms. If you have a dynamic pool where, like the one I showed earlier, where min was 2 and max was 4, that pool's going to grow and shrink. And they know in the morning when people come in to do work, the pool's going to have to grow. So the database is going to have to allocate resources. But the people who already have a connection are also trying to do work. They're trying to do queries. And so the database gets doubly overloaded. They don't like that. They think that's a common cause of problems. And so they prefer that you actually use a fixed pool size. Now, our recent recommendation actually with new versions of the Oracle client stack is probably to set pool increment greater than 0. Because if there's a catastrophic failure and these network disappears for some reason and comes back, so these are all invalid, then you want the pool perhaps to grow a little faster. That if you have a pool increment of 0, it translates to an increment of 1 when it has to reestablish itself from the ground up. So you may want to have a slightly bigger size there. The Oracle Net layer itself has various parameters, connection rate limits, so you can reduce the slamming of the database in those catastrophic morning events, what used to be the 9 o'clock Monday morning. Fixed pool size doesn't suit everyone, but certainly it's the best case recommendation and the best starting point to look at. So how do you do tuning? So we have, actually, this was formalized in our 5.2 release mid-year, so we changed some of the names. The old names still work and you might see those around. But we now have the parameter called enable statistics, and you can set that when you create the pool. That will record some statistics, such as particularly the pool queuing. So you can see if the pool queue grows and people are waiting for connections, and that means your pool is a bit small. And then you can actually print out those statistics. You can either get them as an object and do what you like with it, or you can just dump them straight to console for ease of quick debugging. And if the pool is not sized the way you like it, or you want to change some of the other parameters, then we have a new pool reconfigure function. And you can actually turn statistics on and off with that, so you don't always have to have statistics enabled throughout the life of the application. In practice, we do see people run with statistics always enabled, and they just log off these statistics and then do whatever post-processing analysis they want to do later outside the application. But this is certainly useful to check that pool queue size and the pool size itself. So availability, always a hot topic. Everybody wants an immediately usable connection no matter what. and they don't, for some reason, you developers don't like actually having logic in your code which says, did I get an error back? Oh dear, I have to go and fix it up and reconnect and rerun my statement. You want us to do the work, which is fair enough. You want your apps to look nice and clean. But there are two sort of standard cases where connections can fail. One is if the network drops out, as you can see there at the top X, and the other is if the database resource limit has been exceeded or some other event has exceeded. Database DBA might have killed a session, for example. So these are just a fact of life. Now, one thing with the pool is that for performance reasons, if one of these errors happens, the pool doesn't know about it. We're not constantly checking, is everything okay? Is everything okay? Is everything okay? That would just impact scalability and performance. So from the application point of view, this object, the connection object, seems to be okay. Get connection will work. And it's only when you try and do something on that and it tries to send something across the network when you get an error. Now, having said that, it's not quite true, particularly with the newer versions. If you're using newer versions of Oracle client libraries, there's always a very lightweight socket check. So that first case will be discovered when you try and do your get connection call, and you will not get an invalid connection back from that first case. The pool will say, oh, this connection is not available. This is internal to itself. Find that it's not usable. It'll go and reestablish a valid connection to the database and give you that back. It still doesn't do that round trip ping across to the database to see if the database still thinks you're okay. But we have this thing called pool ping interval, and the default is fine for almost everybody. You probably don't need to change that. But that will do a round trip ping in some cases if that connection hasn't been used for some time. There's a possibility it might be stale. Obviously, if the connection pool is being frequently used, you kind of know that everything is good because those connections would be cleaned up automatically if they weren't. In the recent versions of Node Oracle DB in 5.2, we've kind of coalesced a lot of error messages. You used to see things like RO3113s, RO3114s. Used to have to handle a number of different error conditions in your application. Now we are returning a single DPI 1080 error back to the application, and it will have the base error there in the message. So it would be like an RO3113 in the text of the message, but the error code itself will be DPI 1080. And so that makes it a little easier for the applications just to say, is my connection valid or not? If you try and use a valid connection, you'll get a different DPI error. But basically, we're trying to do a lot of the work for you. So first suggestion, keep up to date with the Oracle client, use the latest you can. And still you need to do error checking after your executions because network dropouts can happen at any time. So you still need some kind of logic in there, in my mind. I mentioned network before. There are some settings that you can set there. Outbound connect timeout. This will, and when you try and do that get connection, or when, if you're doing standalone get connection, or when the pool is internally creating a connection to pipe across to the database, this will limit the amount of time that can take. And so you can get an error back faster if there's a problem, and your apps can be more responsive to the users. Similarly, things like receive timeout and send timeout. If you're actually doing a SQL statement, not getting messages back fast enough, or sending messages fast enough if nothing's been sent across the network, then the application will get an error back. Expire time is useful. It sets the TCP timeout, so you could use this perhaps instead of tuning the operating system. And that can also give you faster, what we call dead connection detection, or rather sort of dead server detection, because if the application can't detect the server, then you want to get a message back faster. The other advantage of expire time is it does actually send those packets across the network, lightweight packet, just to the listener. And if you have a firewall which is expiring messages after expiring idle connections, if the connections are sitting there not sending anything back across the sockets there, the expire time will send a ping backwards and forwards, so something like a firewall won't go and kill those idle connections. So that can be useful in some situations. We have an example if you're using Azure Cloud connecting to Oracle Cloud with a database in Oracle Cloud. Azure Cloud will kind of kill idle connections after about 4 minutes. So in that case, you'd want to set expire time to about 2 minutes, about half the kill time. As you've read ahead, new syntax means you don't have to have all of these things in configuration files. You can just set these in the connect string itself. And in fact, in 21C, you can also pass some of those database residence connection pooling parameters that I mentioned before, and that's something we're not going to talk about, but there's an enhancement there if you haven't caught up with that. Back in Node Oracle DB land, there's an attribute called Timeout, which actually is kind of like the send and receive timeouts. So you can set this at the connection level, and if you don't get messages backwards and forwards fast enough, then your calls to the database will return errors to the application, so they won't sit there for a long time. And obviously, higher end, use FAN, fast application notification, get events for like planned downtime. So the session pools can gracefully clean up and perhaps connect to another rack instance. Application continuity does do some replay of work that your application has done. If the database instance has disappeared, Oracle Client Libraries are recording that work, and they can actually replay it against a new connection to a new instance of the same database. So we have some higher end things there. But these are things I used to call easy or cheap availability. In fact, things like application continuity, it's just enabled with a service setting on the database, and perhaps even easier than fiddling around with some of these things from the application point of view. It's all easy anyway. So time is running out. This you probably already know. It's a fundamental thing here with API design is we want to reduce those round trips to the database. Messages going to the database, network listener has to wake up, it interrupts, it can't handle anybody else's work who's trying to do some real work. Something has to be marshaled on the database side, sent back to the user. That whole round trip impacts the scalability. And if you can reduce those, the system can be more efficient, more scalable. Applications tend to then be faster. So there's some ways to do this. You don't want to be connecting too much. Use a connection pool, use client result caching. You don't want to be over committing or rolling back. Those are extra round trips. You don't want to be selecting more rows than you need from your data sets. Don't do an explicit ping across the network. Node Oracle DB has an explicit ping function. Don't overuse that, because all of those things interfere the database operation in the scalability sense. So one common case we often see, one common pattern we see is that people do get a connection and then they try and set some session state. So alter session, NLS date formats, number formats, time zones, things like that. So that as soon as you do a connection, you have to do a round trip to the database. The database has to do some work. So so don't do that with a connection pool. You will have to do it if you're not using a connection pool. But with a connection pool, use a callback function instead. So we have a session callback parameter, and you set the name of an application level function that you define, and then you can do whatever statements you like in that function itself. And this is, it does have a little callback model, but that's pretty simple to get around with. So whenever you do your get connection call, you're guaranteed that this will have been called. Now, it only gets called for every connection in the pool. And remember, some of the examples before we had 4 connections max in the pool. So this will only ever need to be called 4 times. This session state stays with those connections even when they're released back to the pool for the next person. The next person who gets them out, does a get connection, will get that same session state. So typically in applications, you want everybody to have the same session state. This tag I'm not going to go into, but that's if you want that special case where people need slightly different states. But the standard case is everybody in the application has the same state. So everybody needs to execute these alter statements, and you only need to execute them once per connection in the pool, not once per get connection call. So session state is different from transaction state. Yes, when you put the connection back in the pool, transaction will be rolled back. Little example here, let's scenario, some kind of micro web service gets called 1,000 times, pool has 4 connections max, so we have to do, app gets called 1,000 times, so we've got to get 1,000 connections to do some work. Without the callback, we have to do those 1,000 alter sessions, 1 per get connection. If the app just happens to do 1 query, it's a very simple app, that's going to be 2,000 SQL calls. But if you have the callback, then you only need to do 1 alter session per connection in the pool. And look, you've effectively halved the load on the database in this case. And we do see this. We do see people just doing 1 select statement per get connection. It's not particularly efficient, but that's just the way the app is. And maybe that's all you need to do. So you can really reduce your load by using a session pool. even in those cases where perhaps you only need a single connection in the application, if it's application is going to continue running, you can still save yourself some time, some coding effort by using callback with a session pool of size 1. Okay, so I've got a slight detour into autonomous database. I'm sure you all know about database cloud, and particularly about our always free offering in the database world. Even internally within Oracle, where I have like 4 or 5 different cloud accounts, always free just happens to be the easiest, partly because there's one based here where I am in Melbourne, Australia. So it's fast for me to access the data centers all around the world. There's a little bit of a trick currently with connecting, and I just want to walk you through that. And I think I've got 3 slides, so it should be pretty quick. So there are various forms of the database. There's a JSON database, data warehouse, autonomous transaction processing. Effectively, they're the same database, just tuned for slightly different things. There's effectively the same as you could have on premise as well. So it's all one happy family. That there's no real difference. But if you want to connect from the applications in the C stack, currently we enforce mutual TLS, MTLS. And that means you have to download a credential or certificate, which is stored in a wallet. So in that little small file, small font there's a DB connection. You have to download this wallet, and you'll get a download wallet button. And you might see here that there seems to be an option here for mutual TLS. Now this is all changing as of pretty much last week or so. So the Java people luckily don't need to use this wallet anymore, and this will roll out gradually to the C stack as well. And you can just hear me shouting when that does happen, because it just makes things just that little bit easier. You can still use mutual TLS if you want. Anyway, download the wallet. You just get a zip file, not a big issue. And you can extract some of the files from that. There's 4 or 5 files in there. We only need really 3 for applications. And you just move those to whatever default location you like. If you're using Instant Client, there's a network admin directory. Just stick them in there. Default location. That's it. That's all you need to do. Next slide will show if you're not using that. But you don't need to edit anything. You don't need to set any environment variables to say where those files are. They'll just get read by default. And the TNS names has various connect strings. You can just choose whichever connect string you like. In fact, if you want to use Easy Connect, you don't need SQLite.io or TNS names. You just need the SSO file, and the connect string would be an Easy Connect syntax, and you would actually specify as part of that the location of the wallet itself. So that's also an option there, pretty easy. You just have to get the slashes in the right place and remember where you've put these files. But if you want to put them in some arbitrary directory, if you want to store them with the application instead of with the client libraries, you just move them to wherever you like. And you then, in this case, need to edit the downloaded SQLite.io and actually say where that wallet file is going to be located, that .sso file. Somehow you need to tell Node where to find that, Node Oracle DB where to find that. We saw init Oracle client earlier. There's a config parameter which we didn't see, and this is basically the configuration directory where things like the TNS names, RO files are kept. Or you can go old school and set some environment variable to say, hey, this is where I've actually got all of my configuration files. And again, you just use the connection string from that file. Notice on the cloud, you're still using database username and password. These wallets are not auto login. They don't contain credentials. They just contain the certificate for that mutual TLS support. I have a kind of good blog post on this. So at the end, my blog site, or if you look at Twitter down the bottom, you'll see where to get that. Okay, so that's the end of connection. Really just wanted to speak a little bit about getting data in and out. Of all of the things I chose to talk about today, these are the common things which are important. So we have 3 methods of selecting data from the database. Just a standard execute, you just get all the data back at once in one big hit. If data is too big or you need to process it in chunks, you can get a result set back, which would be kind of like getting a ref cursor back from PL SQL block would be equivalent. That's handled the same way, but for normal select, you set this result set attribute in the connection parameters, the execute parameters. And we also have query stream. So this will then give you a series of events where each row event will give you a single row of the database. Sorry, each data event will be one row of the database. And the important thing here is how do we tune this? And this is the common case again where people are selecting data. We often see people use our scripting languages for big data pumping, medical world, large data sets going backwards and forwards. You want that to be very efficient. Spoke about round trips before. You want to reduce the round trips, and one way to do that is with these two tuning parameters. And you might ask me why we have two tuning parameters, and the answer is buried deep into the internals of Oracle and the way it actually has two levels of call, an execute call and a fetch call, which we hide from you just by wrapping everything up here. Bottom line is, although we tried hard to just go down to one, it turned out to be better to let you have more control over this for optimal tuning of applications. They operate on different layers of the code. They don't affect how rows are returned to the application. Doesn't matter which of those three methods you're using or how many rows you're actually going to get out at the end. They're just internal buffer tuning parameters. So if you have a large data transfer, you want to be bumping up from the defaults, and you have to choose whatever works for you. An interesting case, though, is if you are paging data. So if you know you only want to get 20 rows back, then do this trick. Set fetch array size to the number of rows you know you're going to get back, and prefetch rows to 1 greater than that. And that's, again, this internal implementation stops an extra round trip to detect end of fetch. I've got some little graphs, charts at the end to show you how this plays out. Obviously, your syntax, if you haven't caught up yet, offset fetch next, very useful. And don't forget, of course, if you're going to be paging data, you want to be using bind variables for whatever the offset might be if you're paging from a different starting point of the data set. So make sure bind variables come into your world. And the simplest case, if you're just fetching a single row, yes, you could leave everything at default, but alternatively, you could just reduce the size of the buffers right back down to 1. Prefetch 2 is that +1 that I spoke about on the previous slide, and that's the default, so we don't even need to set that. So what have we got here? Default sizes, 2 and 100 are the default sizes. If you're just fetching 1 row, it's only going to take 1 round trip to the database. But if you start bumping up the number of rows that you're fetching in whichever method you're fetching, then that number of round trips dramatically increases. And so that's when you want to start looking at some tuning. Yes, of course, same number of rows, you're fetching 10,000 rows. No matter what you tune, the same number of rows comes back, just how efficiently it comes back. And so, as you can see here, as we start bumping up these values, then the number of round trips drops significantly. And a little kind of quirk here is, I changed the default prefetch rows from 2 to 100, actually dropped the round trips by 1. That may be pretty insignificant in the scheme of things when you're doing, still doing a significant number of round trips for very large data sets. You may find that prefetch rows actually does 1 extra memory copy just in that very first case. You may find that you just leave this default and you just do your tuning with array size. And then the interesting case, as I showed before with paging, is setting that prefetch to the 1 greater than the actual number of rows you want to get back, drops that round trips down. So we don't do that extra round trip to check end of fetch. We just right back down to as scalable as we could be. So let's look at lobs. So lobs in Oracle are always a little interesting. We have done a lot of work here in the driver to make them as easy to use as possible. And for anything up to about 1 gigabyte, you can just deal with them as strings. Sadly, the default for historical reasons is to have a lob class which you can stream from, which is certainly usable if you have very, very large lobs. But everybody else probably just wants the data back as a string. They're probably just using megabytes rather than gigabytes of data. So they just want to, give me my data. I just want to select it and deal with it and see it as a string or a buffer if you're using a blob. So we have a couple of ways to do this. There's a global setting, which I don't show, but if you're doing it at a per query level, you can use this fetch info. And here, clob, so we're using a string, blob, you'd use a buffer, and this will just give you data, as I say, straight back. The advantage of this is it reduces round trips considerably. The lob implementation was sort of designed for a different use case, which was those large cases of streaming, video. People remember Oracle Media Server and things like that. We're not really in that space, most of us, and this actually turns out to be very efficient, much faster than trying to deal with a lob instance and trying to get your own streaming back from that, even if it's the same data size. So you turn this on, you probably turn this on as a global setting called fetches string or fetches buffer. So that's getting data out. That's all I've got to have time for that. So we need to rush on to have a look at single row DML. And this is pretty easy, as you know. Auto commit is something which I see which is overused. Now, auto committing is good when it's used properly. It saves a round trip to the database. If you do an explicit commit, that's a one round trip to the database. Auto commit is piggybacked onto this execute. So it's, halves the number of halves the number of round trips for a single insert like this. But if you're inserting a lot of data, 1, 2, 3, 4 rows, 2 different tables, whatever, you don't really want to be auto committing. Obviously, that destroys transactional consistency. You can't roll back everything, but it's also inefficient from the database point of view. So the sort of recommendation is you don't auto commit until the very last one, and then you auto commit at the end. Easier said than done in the sort of applications when you're trying to abstract things out, but that's the best practice recommendation. But if you're inserting multiple rows, round trips come into play. So we have an execute many function, which handles arbitrary number of rows, obviously up to some network limits. If you're inserting huge numbers of rows, you may need to call execute many a couple of times, but you can certainly send batches of rows all at once. Again, there's an auto commit option. There's an optional bind defs, and this is really just to do with sizing, because if you don't pass this, then we're going to be guessing internally on the memory size we need to allocate for each of these strings. And if we suddenly see a bigger string, then we're going to need to reallocate everything because the way it works, it needs all of these data sizes to have the same width in terms of memory allocation. So use this for optimal performance. Obviously, rows result, well, this is result, but rows affected is 2 rows. We inserted 2 rows. Bind variables, again, important. Noisy data, you're often using data loads. In this case, pretend I had a unique key, so these are going to be invalid data points and not going to be accepted by the database. It's going to be an error thrown. By turning batch errors to true, when I do my execute many, then I magically get, in my output, I get rows affected. So 1 row was affected, so I managed to insert 1 row, but I got some errors with the other rows. So offset 2, actually I've faked this and I faked it wrong, but anyway, that's 2 and 3. Actually, this should be 1 and 2 because it's actually 0-based. Apologies for that. I was trying to fit everything on the slide. But basically it's saying, there are a couple of errors where the can't insert nulls into this table. And at this point, I've got 1 row in the table and I can decide now, do I go back and clean my data or do I just ignore it? And then I can either commit or roll back on the table. And importantly, if I had auto commit set here, then that would have been ignored in this case. So it would not have committed partial data. It would force me as an application creator to work out what I wanted to do with this data and then explicitly commit or roll back. So simple graph, again, kind of showing this round trip costs. So earlier I was showing round trip counts for querying. Here's the actual time-based. And you can just see that for the execute, as the number of records goes up, the time just goes up dramatically. This is just the graph. I mean, it's just staggering that the difference. This was for a single number in a short string. Had a local database, so your mileage may vary depending on your data width and your distance across to your actual application. Bottom line for tuning for fetching with the array size and with this for execute many and the batch size is you need to be testing your production systems because that will show how loaded the database is. It'll show the network speeds. You can get a fair way with your development environments, but it's perhaps not until you're in production that you can really fine tune some of these things. And if you are doing data loads, use data pump where you can. It's often the easiest way to do things. I didn't show it on the earlier slide, but you as Oracle people know that you can turn off things like indexing and logging and things like that, which can also improve performance. So I've just got a couple of slides in the last minute and a bit. Oops, that's batch errors. And we can then rush on. Let me just check. I'm getting a chat, which is probably the hurry up. No, it's not. So JSON in the database. SOTA simple Oracle document access by default uses JSON, stores JSON in the database. Doesn't have to store JSON, but by default it does. So pretty much we just talk about it as if it's JSON centric. NoSQL style APIs in a number of languages, Python languages, C, Java, REST, etc. The storage in the back end is actually managed by tables. So it has all of the standard and obviously well-tried and trusted capabilities of tables, performance and reliability. So there's not new code there. You don't need to understand SQL, but because things are stored in the tables, if you really want to dig into it, you can actually run things like analytic statements over those tables. But generally, you don't need to. So it has a standard database. This is almost like a placeholder sort of database, just a call to get this. Collections, a collection really is like a table, if you want to think about it like that. And then documents are rows in the table. To work with those objects, we have a SOTA operation, so you class, so you can do filtering and query by examples, removing, counting documents, etc., etc. You get a cursor if you need to, or you get the the final document in the end. You can access this as JSON object or buffer, depending on the application needs. So I think I've got 3 or 4 slides on this left. You need some permissions in the database, nothing magic there. In 5.2 of Node Oracle DB, we now have a SOTA metadata cache, and you really want to use this, and you'll want to be using new client libraries because there's some very significant performance benefits by using this. Obviously get connection, do this sort of placeholder, say I get a SOTA database, and then I can open the collection if it exists or create it if it doesn't. I'm doing it this way because this one actually uses the metadata cache, whereas create, which by default will open an existing connection, doesn't use the cache. So this is the best pattern. And you can see that we can insert data just straight JavaScript object into the database. If we want to get some of that metadata back that's automatically inserted, we can do insert one and get. If we want to use our own explicit metadata, we might use this create document command and actually construct the document itself before we insert, instead of just passing in the JavaScript object. Auto commit's always contentious because SOTA team likes to have it on. I just spoke about the performance issues. We have insert many and get, so the array fetch, the execute many kind of equivalent, so use those instead. But auto commit's there to use if you want. And we obviously have find. We have the sort of operation builder, so you find, pass it a key. Find, pass it a key, and I can actually get the content of the document, and whichever format I like, straight JavaScript object or a string if I want to pass that down through to, say, some web service. Filtering, I just have this as the last slide, and we have a whole bunch of operations, regular expressions, etc., etc. So again, building up this kind of operation builder, and at the end there's a terminal operation statement here. In this case, it's going to get all the documents which match this filter, and I can just iterate through those, get the content out of those documents, and print out any attributes within that object. So that's a really easy way if you don't like your DBAs enforcing table structure on you. Just put everything in a JSON document, and you can use it in all those APIs that I mentioned before. So I've got a little bit over time. I hope you have found that worthwhile. We do have a lot of content out there on our manuals, installation manual, user guide, API guides. And obviously we have forums and Slack channels and all those sorts of things. If you want to ask questions, just hop on, just become part of the community on GitHub or Slack, and just let us know what you're doing with this product. We certainly have a large number of customers out there. It's always great to hear from you. And thank you very much for your time, and thank you to the conference organizers for letting me speak today.